Hello and welcome to the first chapter of our course on ISO 8583, Transaction Processing from Terminal to Issuer. We are still in the big picture chapter to discuss the high-level elements that you need to understand before we get into anything technical. In this sixth video, we are going to discuss message switching and routing. Let's start with a definition of message switching. It's a mode of data transmission in which a message is sent as a complete unit and routed via a number of intermediate nodes at which it is stored and then forwarded. Message switching happens every time a system receives a message and has to forward it to another entity on the payment chain. One reason is that the protocol used for the next message transmission might be different. So, for instance, a message received from a payment terminal will be very different to the one subsequently sent by an acquirer to a payment network. But even if the protocol is the same, the settings on the interface might be different. For example, a payment network is never going to just take a message that it received from an acquirer and send it as is to the rightful issuer. They are always going to make some changes to this message and add data to it. Also, if the message contains an online PIN, at the very least, the PIN block will be re-encrypted with a different set of keys. So, message switching happens many times in the lifetime of a payment transaction. And there are not just external messages to think about. Every payment switch has its preferred internal message protocol, which causes additional switching. Let's have a look at what might happen when an acquirer receives a message. Let's take a simple example. The acquirer can receive payment messages from an estate of terminals. For this, the acquirer has a terminal interface on their switch, which can accept many inbound connections. And each terminal communicates with the acquirer over this terminal interface. The acquirer can also receive payment messages from third parties, such as terminal integrators or value-added resellers, and so on. For this, the acquirer has an interface dedicated to third-party connections on the switch, and they use this interface to exchange messages. Finally, the acquirer can receive payment messages from an estate of ATMs. For this, the acquirer has an ATM interface on the switch, which can also accept many inbound connections. And every time someone withdraws money from one of those ATMs, the ATM uses that interface to communicate with the acquirer. On the other side of the picture, the acquirer can forward payment transactions to Visa. For this, the switch has an interface dedicated to this connection with Visa, which is a secure static IP connection. And they have an agreement with Visa that they will use the dual message Visa protocol. In the same way, the acquirer can forward payment messages to MasterCard. For this, the switch also has an interface dedicated to this connection with MasterCard, which is also a secure static IP connection. And they have an agreement with MasterCard that they will use the dual message MasterCard protocol. To connect all those interfaces, the acquirer switch has a central router with a complex set of rules and checks. And every interface is connected to this central router so that messages can go back and forth between the left side of the picture and the right side of the picture. Let's zoom in and focus on what happens to messages coming from the terminal interface. Every interface on the payment switch has a message converter. You can think of it as a process or a daemon, or more generically a piece of code. It reads the message in its original format, extracts all the useful information, and then generates a message in a different format using this useful information. For example, the terminal interface will have a converter that takes a terminal message and converts it into an internal format. Every payment switch has its preferred protocol for internal messages. This converter has a way to communicate with the central router so that it can pass on the internal message that it generates. In the same way, the Visa interface has a message converter which can take messages in the internal format and send them to Visa in the Visa format. This converter as well has a way to communicate with the central router so that internal messages can come to it. and the exact same thing exists for the MasterCard interface. Each converter works both ways, so that, for instance, internal messages can be converted to the MasterCard format to be sent out to MasterCard, but also that responses from MasterCard can be converted back into the internal format. Let's go through an example. A message originates from a payment terminal and is sent to the acquire switch over the terminal interface. The message is then converted to the switch preferred protocol, which turns it into an internal message that contains the same information as the terminal message. That new message is then sent to the central router. The router will typically send copies of this message to various processes. Those are processes that allow the acquirer to run all kinds of checks. For example, a copy of the message might be sent to a process that verifies the terminal serial number. This will protect the acquirer by ensuring that people are not using replacement terminals that they may have hacked. A copy of the message might also be sent to a process that manages statistics on the switch usage. There are many such processes taking place inside an acquire switch, and they mostly depend on how an acquirer's business is managed. All those processes will then inform the router that the process is finished. And when they are all finished, the central router can then decide where to forward the transaction to. A switch typically contains a bin table, which has to be kept up to date, and contains a mapping table between bins and interfaces. The bins are usually supplied by the payment networks, but they might also come from other domestic institutions if the acquirer has an agreement to forward domestic transactions directly to those institutions. This bin table allows the router to make a decision on which interface the payment message must go to. The message is then sent to that interface, which has a converter to turn it into an external message. And that external message is sent to the payment network over the communication line that exists between the two systems. This concludes the last video in this first chapter. Thank you for watching it.